So looking into the future, next steps. We were kind of intentionally a bit fuzzy about this timeline, but we're going to try to make as much progress as we can. Obviously, it's with a very constrained budget, but we're going to try to make as much progress as we can on the elements of the interplanetary transport booster and spaceship, and hopefully we'll be able to complete the first development spaceship in maybe about 4 years, and start doing suborbital flights with that. In fact, it actually has enough capability that you could maybe even go to orbit if you limit the amount of cargo with the spaceship. Well, you have to really strip it down. But in tanker form, it can definitely get to orbit. Can't get back. We can get to orbit. It actually starts thinking like maybe there is some market for really fast transport of stuff around the world, provided we can land somewhere where noise is not a super big deal. The rockets are very noisy. But we could transport cargo to anywhere on Earth in 45 minutes at the longest. So most places on Earth would be maybe 20, 25 minutes. So maybe if we had a floating platform out off the coast of, say off the coast of New York, say 20, 30 miles out, you could go from, New York to Tokyo in, 25 minutes. Across the Atlantic in 10 minutes. Really, most of your time would be getting to the ship. And then it'd be real quick after that. So there's some intriguing possibilities there, although we're not counting on that. And then development of the booster. We actually think the booster part is relatively straightforward because it amounts to a scaling up of the Falcon 9 booster. So we don't see a lot of sort of showstoppers there. But then trying to put it all together and make this actually work for Mars. If things go super well, it might be kind of in the 10-year time frame. But I don't want to say that's when it will occur. It's like there's a huge amount of risk. It's going to cost a lot. Good chance we don't succeed, but we're going to do our best and try to make as much progress as possible. And we're going to try to send something to Mars on every Mars rendezvous from here on out. So Dragon 2, which is a propulsive lander, we plan to send to Mars in a couple of years, and then do probably another Dragon mission in 2020. In fact, we want to establish a steady cadence that there's always a flight leaving, like it's a train leaving the station. With every Mars rendezvous, we will be sending at least a Dragon to Mars, and ultimately the big spaceship. So if there are people that are interested in putting payloads on Dragon, you can count on a ship that's going to transport something on the order of at least 2 or 3 tons of useful payload to the surface of Mars. Yeah, so that's part of the reason why we designed Dragon 2 to be a propulsive lander. Is as a propulsive lander, you can go anywhere in the solar system. So you could go to the moon, you could go to anywhere really. Whereas if something relies on parachutes or wings, then you can pretty much only, if it's wings, you can pretty much only land on Earth because you need a runway, and most places don't have a runway. And then any place that doesn't have a dense atmosphere, you can't use parachutes. But propulsive works anywhere. So Dragon should be capable of landing on any solid or liquid surface in the solar system.